Fundamentally, every facility is an enclosure partitioned into multiple spaces that are tailored towards similar or different functions. In other words, every building comprises spaces demarcated or enclosed by interior and exterior surfaces. And the functions of the spaces and the materials or construction types of the surfaces inform the loads, equipment types and sizes, and the overall mechanical design of a facility. Earlier, we made some basic assumptions through the energy settings. We've also created a conceptual HVAC design of the facility. However, to generate actionable reports that are based on these assumptions and concepts, we must produce an abstract form of the facilities, spaces, and surfaces, known as analytical spaces and analytical surfaces, contained within an analytical model. In this video, we'll create our project's energy analytical model. So start by opening the file you used in the previous video or analytical model in the chapter 1 exercise files folder. So at this point, navigate to exercise files folder on your PC. From the chapter 1 folder, open this file, analytical model, which I have here. Then open the default 3D view. If the linked architectural model is hidden, use the reveal hidden elements to unhide it. After that, launch the visibility graphics dialog by typing VV or VG on your keyboard. Then from the model categories tab, hide all the categories and leave only the following: ceilings, columns, curtain panels, curtain systems, curtain wall mullions, doors, floors, masts, roofs, shafts openings, structural columns, walls and windows. Then click OK to close the dialog. Next, go to the Analyze ribbon. From the Energy Optimization panel, launch the Energy Settings dialog and make sure that this parameter, Use Only Elements Visible in Current View, is checked. Now from the same Energy Optimization panel, click the Create Energy Model button, then create the Energy Analytical Model from the following prompt. This will take a while and generate the analytical model for this project. Now, to review this generated model more closely, we need to turn off the model categories and external links. To do that, go back to the visibility graphics by typing VV or VG. Disable Show Model Categories in this view and disable the visibility of all the linked files. Then from the analytical model categories, turn on the visibility of all the categories and subcategories. Then click OK to close this dialog. So this is our energy analytical model for the facility, and a lot has happened by generating this energy analytical model. First, when you expand the zone equipment from the system browser, you will find the analytical spaces that are serviced by the zone equipment. And when you select any of the analytical space, you will find detailed information on the properties browser. Such information as the constraints, dimension, mechanical flow, identity data, phasing, and energy analysis. Now, some of these parameters are currently not computed because we still need to run the systems analysis. And interestingly, some of the properties of the analytical spaces originate from the MEP spaces in the same location. For example, you can see that these spaces have name and number assigned to them. Also the outdoor air information and whatnot. These information mostly are extracted from the MEP spaces in the same location. So when you look closely here, you see that these spaces sit in the same location with the MEP spaces. Now also recall that the MEP spaces themselves got some of their properties from the architectural rooms. Remember that we use the space naming utility tool to transfer the room names into the space names. So bottom line, always begin your MEP projects with an architectural link and extract as much information as possible to guide your design and analysis. Now, beyond all this, generating the energy analytical model also produced new views in our project. It created two 3D views. When you scroll through here, you see under 3D, you have these analytical spaces which will have open, and the system zones, which shows the system zones we created in the previous video. Beyond that, it also created two schedule views. When you scroll through the project browser down to schedules, you will discover there are two new schedule views. The first is analytical spaces. So the analytical spaces schedule offers a unified view of the properties of all the analytical spaces in a project. And one thing you notice there is analytical spaces that don't have unique names, like these ones here. So when you select any of them, you will notice that they fall under unconditioned under the system browser. So these are usually small spaces in the building, like the ceiling voids that have been exempted from systems analysis, and that's because their height or chase area fall within the thresholds established in the energy settings. So recall, when we configured our energy settings, there were these two parameters here that were left at default. So when an analytical space height or chase area fall within these thresholds, they will be exempted from the analysis and assigned to unconditioned zone equipment. Then also we have the analytical surface schedule. So this gives you an idea of the surface and opening types in the analytical model and their areas and counts. So when you open the analytical model here, when you select a surface, you can see the surface type. This is an exterior wall. When you select an opening, you see that this is an opening type operable window. So this schedule summarizes all the surfaces and opening types that you have in this analytical model. And the good thing is that you can further customize both schedules. I mean, you can always go to fields and add new parameters. You can sort and format and whatnot, just like you would do for any Revit schedule. And we'll also look at that later in this course. Now, one last thing I want to demonstrate is the importance of this parameter in the energy settings, which is this parameter use only elements visible in current view. To emphasize the importance of checking this parameter, when I uncheck this and then I generate a new analytical model by going to the default 3D view, I'll delete the existing one and create a new one. So one thing that unchecking that parameter does is that it generates lots of unwanted spaces. For example, when you look at this ceiling void here above the first floor, you can notice that there are lots of unwanted spaces that have been generated. And from the system browser here, you see that most of those spaces are categorized under unassigned. And that's because they don't intersect any system zones boundary. Thus, they have no zone equipment assigned to them. You can also see things like balcony and whatnot that we don't need to condition, and they've all been added to our analytical model. So in simple terms, unchecking that parameter can introduce lots of analytical spaces that are beyond your control, and they can skew your analysis. So to get rid of this, we need to go back to the energy settings, and then we'll check this parameter back. Then we go back to our default 3D view and generate a new energy analytical model. So you can see that this is much more refined and based on our settings. So that's it. We've created the analytical spaces and analytical surfaces that are serviced by their respective zone equipment for our facility. Now, with all the information generated so far in this chapter, we're ready to run the system analysis and produce even more results. And that's the focus of the following video.